The most important aspects of developing a comprehensive O&M plan overall, okay, is the initial inventory of the building systems. So going back to that central plant, we would have went through and spent hours cataloging equipment. Okay. Somebody asked if they had a computerized maintenance management system. Remember that? And their answer was yes, it was MP2. So the next question in regards to quality is how much of that equipment is in their CMMS? And how often do they go back and reassess that equipment? For either condition-based, what's the condition of the existing pieces of equipment, what's the reliability, and what's their overall performance levels, okay? So getting back to this, assets, utilities, tasks, operating procedures. In other words, it's going to be the entire process. So that's the entire inventory for your entire building, okay? Why would that be so important? John, what do you think? How come that would be so important? To John in, not to John in the blue, but to John in the red shirt. Why would that be so important?
Just to know where you stand with everything?
Yeah, right? Because you have to have a starting point. To come up with a comprehensive maintenance plan, I've got to know what I have, what condition if it's in. If it's a brand new building, it's just barely been turned over, I got my certificate of occupancy, it's just barely been turned over for me. Hey, you know what? I may have a couple months to come up with this plan. But sometimes we inherit what we get. As a facility manager, you inherit the building and the operation and the systems. So when it's handed to you, now you start to educate yourself. The best way to do it is to conduct an inventory, okay, for your equipment. So some key inventory needs is what's the needs of the facility. So you're going to base it on what type of building. Administrative? Is it a medical building? Auditorium? Convention center? Airport? So what's the needs of the overall building and its function? So as you identify the needs, you're also going to identify the priorities. If I have a warehousing facility, my conveyor systems, right, logistics, racks, docks, dock doors, those are going to be critical for the operation. Okay, so when I start to do my equipment inventory, those are some items that I'm going to highlight. Does the current infrastructure need these needs? So do I have too many dock levelers for this warehouse? Do I have too many roll-up dock doors? I don't use half of them. I can idle the rest and eliminate some maintenance if I don't need to. Or do I need more in some cases? Okay. Do they meet the needs, okay, in the most cost-effective manner as possible? Again, I'll go back to the central plant example. If we could determine the cost between the older pumps versus the newer pumps, what's the reliability factor on those? Okay, that would give us a clue as to which type of pumps would be the best replacement pumps, which brand and installation, right? And then also the design, okay, which would be the most applicable, okay, for that particular one. And what's the overall maintenance quality? I don't know, what's your thoughts? What was the overall maintenance quality on our tour that we took? Some of it, yeah, you can probably question and argue a few. And then other ones, I mean, it was operational to what they needed it for, right? So, yeah. But from a visual standpoint, yeah, yeah, yeah. 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 But say, for instance, you were assigned as a facility manager for that central plant here at the school. Conducting your equipment inventory would take you to that first level. And then meeting with the technicians. You don't asking them. And then asking the customers from an operations component, right? Okay. Do the building systems require specialized training to perform the necessary maintenance practices? Now, he had shared, right, that he has chillers. He had 10 2010 chillers, good-sized chillers. But he had an in-house technician, didn't they, that performed the basics of the annuals, punching tubes. Remember that? The larger repairs, though, he out-tasked. So, again, he's determined what he can do internally, in-house, with the resources he had at hand, and what's going to be optimal and what he needs to outsource. Okay. So, again, condition assessments define the needs. So now we determine the condition of the equipment. What's the working order of the equipment? Getting back to that reliability performance component. Okay, how well does that one operate? Okay, and how reliable is that piece of equipment? verify maintenance frequencies, determine if the maintenance quality is appropriate, and then validate the tasks associated to the piece of equipment. And note and rate identified deficiencies by criticality. So how critical would those be? So in our central plant, we know that during the summer, because what he was talking about thermal right now for thermal storage, he runs most of the cooling for most of the day. So he was doing that. Why was he running thermal? It's cheaper because he's what? He's running his chiller at night. Yeah, right. So he recycles, cools it back down when it's off peak. Right. So when the peak comes again, then he's using his thermal. So again, it's optimizing energy. And now we get to the design assessment. Okay. Now you're going back what? This is what I call my CSI work. So have any of the areas been assessed, have undergone some sort of substantial changes? So maybe this is a TI. Maybe we converted an auditorium into a large manufacturing facility. So from a warehouse or auditorium to a manufacturing facility, first things I'm going to come up with is power capacity. I may not have enough power for the equipment. So my design for this original building has changed. I've added more large panels. I added more conduit. I added more electrical distribution systems to support that equipment. Okay. Does the building comply with current codes? What would building codes have to do anything with maintenance? Anybody have some ideas? Martin? Building, you know, what do you got? Building codes, you got plumbing codes, electrical codes, what else? You got the mechanical codes? Good. Good. Okay. Access, yes. And some of those may tie right into the code. Just elevator rooms. Mechanical rooms would be tie into that. Okay. So sometimes the codes are going to be what? It's going to be an ally to your maintenance plan. They have to design per code, one, to get your certificate of occupancy, but also have a reliable and safe system. What necessary renovations, upgrades are required to bring the building systems up to code compliance? Okay. I'm sure that during your career, as you go through project management construction, you're going to come across a project where you will see code violations. The question will be is how are you going to get those code violations, deficiencies, right, corrected? They have to be done. One example is ADA. It happens on a regular basis. You have a restroom that was installed, say it was installed 40 years ago before ADA. Now you're starting to renovate these restrooms as part of a 40,000 square foot renovation, tenant improvement project, right? First thing you're going to get hit with is ADA. So openings, automatic closures, changing the stalls, sinks, everything pertaining to ADA and accessibility laws and regulations. Okay. Air conditioning. Air conditioning systems that were installed 40, 50 years ago are different code from what we have now. So those are going to have to be assessed. Yeah. So who's going to tell you that you're out of code compliance?
Hopefully your engineers.
Yeah, right. Your MEPs and your architect. They're going to identify what's out of code compliant, right? What's going to be acceptable, what's not going to be acceptable, right? So once those are changed, and then here comes your maintenance program. Because now you've got a new infrastructure that's been installed. Okay? And can the existing control system support these upgrades? Case in point, I had a small renovation. It's that area you walked by in the 1360 area at the Hayden. Yeah. That's going pretty quick, isn't it? Okay. Well, I'm talking about life safety. So when we went through, that's about, I don't know, 4 times the size of this room here. But when we were going through the renovation, we found out that our enunciation panels for our evacuation systems, strobes and evacuation horns, they were overtaxed with this room. We had to install 2 more for this room to make it code compliant, part of the renovation. But you trace it back, my controls could not handle 2 more. I was right at the jagged edge, which meant I had to bring in another panel. Well, that panel was $15,000. So guess what? So I've got a new panel with 2 additional connections, and I got 24 left over. So I got capacity now, don't I? which is a good thing. Now I can move on into the future. But one item that you got to ask, can the existing control systems support what you're planning to do? Okay, because again, these are what hidden costs. You've gone through your estimating, right? Project estimating. Okay. Do you try to leave things out of that estimate, that schedule of values? You try to put in as much as you can in contingencies. So one of the questions would be, do the control systems, not only for the evacuation, but security, and also for your EMS, energy management systems. Okay? And then we get to operational requirements, is identifying the building operating standards for temperature. These are regular conditions on a regular building. Every building is going to have these. This room here is going to have, well, back there I can see it now, it's capacity of 40. So you have parameters for the building and for the rooms within the building, okay? So in this case here, typically based on the time of day, weekdays, weekends, or holidays. So this is primarily going to be your lighting and your temperature settings. All the buildings you see in downtown Phoenix, if nobody's residing in them during a weekend, say they shut down at 2 o'clock Friday afternoon and they don't come back in until 8 o'clock Monday, technically that building, high-rise, whatever you want to say, is going to be idled for 24, 48, 54 hours. When I talk about idle, the temperature is probably going to be raised if it's summertime. So if it's typically 70, 72 degrees, it will probably be raised to 78, 80 degrees. Why? Because I'm saving energy, right? Less wear and tear on my equipment. Lighting will be automatically shut down for floors I know I have nobody there, right? So I'm going to have to determine what's the operational requirements for this particular building, because that's also going to support my maintenance plan. Validate and support the needs of the occupants or the tenants and must be reviewed and updated on a regular basis, just like a master plan. So the requirements of the tenants may change. I have a tenant that moves in and their work days are from Tuesday through Saturday. Oh, great. So which floor are they in? Say I got a 20-story high-rise, right? Typical work days are Monday through Friday. I got a tenant that moves in, and their work days are now, work week is Tuesday to Saturday, and guess what floor they're on? They're in the middle floor. My controls support 3 floors at a time, which means I'm cooling 2 additional floors for this tenant on a Saturday. You can manage your controls. But that's going to require a capital. But you're right on, Marty. You're on top of it. It's an item to where we can modify, but the existing controls are not going to support the criteria of that particular tenant. The building was never designed for that. But you can go back and modify it. Okay? So for that particular floor, 2 floors, I can idle down and keep the 1 floor with this particular tenants there. You got to keep the elevators running, right? And I got to keep the restroom facilities running. So the hot water need to keep on for this particular restroom. This is where your controls come in. This is where your energy management system and your sensors can come in to regulate that particular one. One is what I'm probably going to charge this client a little bit more because I have additional labor to support them on a Saturday. So I'm making that, right, and my margins. But on the other hand, though, I'm modifying my maintenance plan for this particular tenant. That's good. That's excellent. Okay. And typical operational, this is just overall lighting levels, okay. Energy conservation requirements, if they have any type of recycling requirements. We talked about the fresh air economizers, free cooling, filtration systems. So typically, in a typical building, these are what you're going to actually embed in your operational requirements. Temperature, lighting, time of day, okay. Filtration systems depending on who the occupant, who the tenant is, okay. And then also for services, okay. Energy management systems, now we're going to flip the sheet and go to the typical energy management program. So this one here assesses the system operations, functions, and performance. So getting back to that same high-rise I was talking about before, identifying what's the optimal use of energy. That's what I'm going to use my energy management system for, right? Because what I want to do, the central plant that we toured, they're optimizing what their use of energy. I'm only using enough energy that I need to use for. Now, here in the Valley, Salt River Project APS, we run about 7 to 9 cents. Maybe on peak or super peak periods, maybe 11, 12 cents. But what about California that runs 17 to 18, or the East Coast that runs 20 to 22 cents a kilowatt hour? Now you start to see the cost, right? Because if I had a large $2 million square foot facility that I had a chance to build in Phoenix or in Boston, I'm comparing everything in it. So I'm comparing what's going to be the energy cost of the facility in Boston versus the one here in Phoenix.
So